sometimes we'll want to find the area between a function and the y-axis instead of the function and the x-axis. But that's okay because I can turn this into a different function and find this area. Effectively what I'm doing is swapping the axes around. And that's my dog. If I swap the axes, I did have, hold on, let me go back and show you. I did have y equals the square root of x. So now I've got x is y squared. So now I'm looking for this area, which would be an integral with respect to y. Integral of y squared, my x value, with respect to y. And then you just plug in your values as you normally would, just working with y instead of x. You don't actually have to do the graph translation like this. You can work directly with this. You just go y is root x, but I need to integrate with respect to y. So rewrite this as x equals something, in this case y squared, and then integrate y squared with respect to y. You don't actually have to draw the graph the other way. Drawing the graphs the other way is just a way to show you what's happening. Of course, we have to be careful of the same things. If my function is entirely on the right of the y-axis, then I can just calculate like this. But if the function is partly on the left, if the function is wholly on the left, then it would be the negative. And if the function is partly on the left and partly on the right, then you would have to do it in two sections, just like we did with the x-axis. So let's try an example. Determine the exact area of this shaded region. So we're looking for the area here between this curve and the y-axis. So this function is a quarter x squared. So y is a quarter x squared. I need to say x equals something in order to do that. So if y is a quarter x squared, then cross multiply 4y is x squared, and x is plus or minus the square root of y. Now, they've now thrown away the plus or minus. And the reason is, I'm only looking at the positive side. There is more of this graph over on this side, but I'm only interested in the positive side. It's a useful trick to keep in mind for later. So then, this is my x. So I want the integral of x with respect to y. The integral of this from my two limits, which were 1 and 9. Well, the integral of this, y to the half becomes y to the 3 on 2 divided by 3 on 2, which they've simplified in one line to 4/3. And then you put in your values and subtract. Again, they've gone units squared because we didn't know what the units actually were.